right, so in 5.1c, we're going to look at radius, arc length, and central angles. Okay, so let's take a step back into geometry days for just a second. Let's talk about a circle. And when you did circles, you know what the radius is, right? From the center out, that is your radius. Now we're talking about a central angle, and that's an angle that starts at the center and goes up, and we're going to call that angle theta. And what we're going to be finding today is the arc length, which is it's basically like the piece of crust on the pizza, okay? That's the arc length. And that's what we're going to use. And look, we're going to have the formula for us right here. S is the arc length, and it's found by the radius times theta. Now, here's the kicker. The theta, we determine if R is 1, S is theta, and the radian measure of theta equals the arc length. Now, why do I mention that? Because we need to make sure that theta is in radians. It only works if our angle theta is in radians. So we may need to incorporate our conversion factor that we've used in the past assignments, all right? So they give us this formula, S equals R theta. We can manipulate that algebraically to get what we need, if we need to solve for R or if we need to solve for theta, right? So let's keep that in mind as we go along. First, it says find the radian measure of the central angle of a circle radius R that intercepts an arc length S. So notice what they're giving us here. They are giving us radius and they're giving us S. So we need to rearrange our formula. So we're going to be finding the central angle. We need theta. So we're finding the central angle, which is theta. So if I rearrange this guy to solve for theta, it's going to be S divided by R, right? So arc length divided by the radius. So if theta is S divided by R on number 1, I would take the arc length of 10 divided by 22 and reduce it, of course. So it'd be 5/11 radians. In my calculator, I'm going to make it a decimal, round it to 3 places, please. 0.455 radians. There's my answer. Don't forget to put radians on your answer, okay, if it's an angle. So look at number 2. Pretty straightforward. Same idea. Theta is S over R. So it's 160 kilometers over 80 kilometers. So our units cancel out, and that's really nice and easy to radians. All right? Look at the next section. Find the length of the arc on the circle, that is S, given a radius S and a central angle of theta. So they're changing up the givens, aren't they? Okay, no problem. But look, our formula is already there, right? It's already in the form we need. So S is R theta. We're going to use that on both of these. All right, so we're just going to plug it in. So 9 feet times pi over 3. That's easy, right? 3 pi. So take your calculator and multiply 3 times the pi and round to 3 places, and you get 9.425. And we put units. Make sure you put units. So this would be feet. On 12, it would be 12 times, look, it's in degrees. So we have to convert this. So 135 degrees times our conversion factor of pi over 180. All right, so we have to convert. Remember, because our formula only works in radian mode. So use your calculator, use the fraction function to do all this multiplication for you. And when you do, you get 28.274, and our units on this one is centimeters. Look at the next set. Find the radius of the circle. So we're finding R. And this time, it's changed up again. They gave us arc length, and they gave us the central angle. So we're going to need to rearrange our equation a little bit, all right? S equals R theta. We need to solve it for R. Well, that's not too hard. R would then be S divided by theta, right? S divided by theta. Okay. So let's do this. S is 3 meters divided by theta, so divided by 4 pi over 3. Okay, remember fractions? 3 over 1, flip it, 3 over 4 pi, gives me 9 over 4 pi. Put it in your calculator, round it to 3 decimals like we've been doing. So I get 0.716 and put the appropriate unit on it. And this one was meters. All right. All right, look at number 2. Notice this is in degrees. We're going to have to put in a conversion factor on this one. Okay. So here's what it would look like. It'd be 8 divided by 330 times pi over 180. Now, how would I do this in the calculator? Let me show you how I would do it. Okay, so to put this one in the calculator, I would use my fraction function like crazy. So I would put 8 over fraction within a fraction. Why not, right? 330 times pi over 180. All right, come on out of there. And I get my angle, 1.389, and this unit would be inches. Okay, so let's look at that last type of question here. Find the distance between the cities. Assume that the Earth is a sphere of radius 4,000 miles, and the cities that are on the same longitude. One city is due north of the other. Okay, so Dallas and Omaha are like directly up 35 from each other, so that makes sense if they're due north, right? So what are we doing here? Well, here's our Earth. It's a sphere, right? And Omaha's here, Dallas is here. We're looking for this arc length right there, all right? So here's Nebraska and Texas. We're going to find that angle difference, and we're going to use that to find the arc length. Okay, so we're going to use that formula, S equals R theta, just like we know. Now, but notice our angles are in degree form, so we're going to have to convert. So how I would set this up is this. We know our radius is approximately 4,000 miles. Now, we want the difference in the two angles, right? So we're gonna, don't worry, we're gonna use our calculator, but we're gonna find the difference. 41 degrees, 15 minutes, and 50 in seconds. Now I put 41 first because it's the bigger angle, okay? It's the larger angle. And I want the difference, and I don't want it to be negative. That would make sense. Then I'm gonna subtract 32 degrees, 47 minutes, 39 seconds. That's going to give that. And then I need to multiply it by a conversion factor of pi over 180. This is where our calculator is going to do a lot of the heavy lifting for us. Thank goodness, right? So let me show you how I would put this in my calculator. Okay, so I just went ahead and entered everything in here just to save some time. But notice I used our DMS format that we've used in our previous assignments. I put in our difference, and I used the fraction feature to do the pi over 180 conversion we need to make it radians. So you're welcome to do this in your calculator like this. It saves a lot of time. It is a lot of keystrokes. So if you don't remember how to do that, make sure you check with a buddy or check with me. But once it's in, it's in. And then you hit enter and it's done the math for me. I'm going to round to 3 decimals like we have been and make sure I put a unit. In this case, I think the unit is miles. So it'd be 591.298 miles.